In our final video for Unit 1, we'll learn how to simplify complex fractions. So what is a complex fraction? Here's the definition. A complex rational expression, or a complex fraction, contains a fraction in its numerator, denominator, or both. Now, a complex fraction doesn't have anything to do with complex numbers or imaginary numbers. It's simply a fraction that contains more than two levels. If you glance down here at our examples, you can see a complex fraction has a fraction within a fraction. Now, we don't want to leave a fraction with more than two levels. We always want to simplify it down to a double-decker fraction. To do that, here's the procedure. To simplify a complex fraction, multiply every term in the complex fraction by the LCD, lowest common denominator, of every fraction present in both the numerator and the denominator, and simplify. So let's give it a try on example 7. We're going to simplify the complex fraction and make sure and express the result in factored form. So on example A, we have a fraction in the numerator and a fraction in the denominator. When you're writing these by hand, sometimes it's easier to make that main fraction bar a little bit longer so you can understand your orientation. So in the numerator, we have a fraction with a denominator of x squared, and in the denominator, we have a denominator of 3x. So we need to find the LCD between those two denominators. The LCD there would be 3 times x squared. So I'm going to apply that LCD to the top and the bottom. I'm going to multiply the top and the bottom by the same thing. Now, just to be clear how the levels in the fraction work, instead of just multiplying by 3x squared, I'm going to write it as a fraction 3x squared over 1. So I'm going to multiply the top by 3x squared over 1 and the bottom by 3x squared over 1. Now, if I look just at this new fraction that I've introduced, that reduces to 1, right? So ultimately, I'm multiplying this fraction by 1. That means I'm not changing its value, I'm just changing its presentation. Okay, multiplying straight across here, notice there's a common factor in the numerator and denominator. So this x squared is going to cancel that x squared. Also, looking at the product in the denominator, the 3's are going to cancel, and one factor of x is going to cancel, leaving behind a power of 1. Multiplying the remaining factors in the top, multiplying straight across, we have 2 times 3, which is 6, and 1 on the bottom, which gives us 6. In the main denominator, we have 5 over 1 times x over 1, which gives us 5x. So our complex fraction now has been reduced to just a double-decker fraction. Now that wasn't so bad. Let's try that same technique on example B. So again, we have a fraction in the numerator and a fraction in the denominator, or a complex fraction. That's my main fraction bar right there. Now, in order to simplify this one, I need to get the LCD of this denominator and this denominator. However, to get an LCD, as you know, we have to have those denominators completely factored. So that's where I'm going to begin on this one. Let's rewrite this fraction as 5x over the factored form, x plus 3 times x minus 3. Remember, that's the factorization of the difference of two squares. I'm going to draw my main fraction bar a little bit longer, and our denominator as is 25 over x plus 3. So looking at the two denominators present, the LCD is going to be x plus 3 times x minus 3. So I want to multiply the top and the bottom by that LCD. And once again, to be clear, I'm going to write the LCD x plus 3 times x minus 3 over 1, just so I can see how it plays with that original fraction. Same thing in the denominator, multiply by the LCD over 1. Now let's execute the product in the numerator and the denominator. So when we multiply the two fractions in the numerator together, notice the x plus 3 cancels and the x minus 3 cancels. This leaves behind 5x on the top, 1 in the bottom, or just 5x. Okay, working in the denominator, we can see that the factor x plus 3 is going to cancel. And that's going to leave behind 25 times x minus 3 over 1, or just 25 times x minus 3. Now, we're not quite done yet, because notice now we have a common factor in the numerator and the denominator. That common factor is 5. So if I divide the top by 5 here, that's going to get a 1, and 25 divided by 5 is 5. So our final simplified fraction would be x over 5 times x minus 3. Notice our original 4-level fraction is now an equivalent double-decker fraction, much simpler. And we're going to leave it in that factored form. Okay, let's try example C. Example C is a little bit different because I've got 2 terms in the numerator and 2 terms in the denominator. But in both the numerator and the denominator, we've got a fraction present. So what we're going to do is the same skill, multiply the top and the bottom by the lowest common denominator of the 2 fractions that we can see. So I'm going to go ahead and group that numerator together and the denominator in a set of parentheses. Now, between this fraction and this fraction, our LCD would be x squared. But I have to multiply the entire numerator by x squared. I'm going to write it x squared over 1, and the denominator also by x squared over 1. What makes this problem different is that we've got 2 terms in our original numerator times our LCD. So that means we're going to have to distribute like so. Okay, now I'm going to write all the details in full glory on this one. If you can do it in fewer steps, that's fine. But 5 times x squared over 1 is going to give me 5x squared. Okay, now on the next one, I'm going to write out the details so I don't lose you. The original fraction there was 2 over x, and I'm multiplying it also by x squared over 1. In the bottom, we'll do something similar. We're going to distribute 3 times x squared over 1. I'm just going to go ahead and simplify that to 3x squared. And then here we have the original fraction 1 over x squared times x squared over 1. Again, if you can calculate as you go, go for it. Okay, simplifying those products, we have 5x squared. This is the product I want to simplify. The common factor there is x, so I can cancel one of those, and that's going to leave behind 2 times x over 1, or just 2x. In the bottom, we have 3x squared plus, notice the x squareds cancel, leaving behind just 1 over 1, or we can call that 1. Now, to follow instructions, we need to write this in factored form, and hopefully you spot that GCF in the numerator. So let's take out an x. That leaves behind 5x minus 2, and the denominator does not factor. So we have taken our original complex fraction and reduced it to a factored, reduced, simplified fraction. Okay, one more problem here. We have a complex fraction, and I've got 3 fractions present in this fraction. So to find the LCD, I'm looking at 3 denominators. This one, and this one. The LCD has to represent each unique factor. So we know the LCD is going to contain an x plus 4 and an x plus 7. So I want to multiply the top by the LCD and the bottom by the LCD. And as usual, I'm going to put it over 1 to be clear. We do have to be careful here because in the original numerator we had 2 terms, right? So I'm going to have to take my LCD and distribute it to each term. Here's what that's going to look like. I'm going to have my first term, 8 over x plus 4 times the LCD x plus 4 times x plus 7 over 1. The second fraction there was minus 2 over x plus 7, and we're multiplying that by x plus 4 times x plus 7 over 1. Okay, here's my main long fraction bar. In the bottom we have another product, x plus 8 over x plus 7 times the LCD x plus 4 times x plus 7 over 1. Now, if you kind of draw back and get out of those details, look at the big picture, notice we have our each fraction, each of our three original fractions, this one, and this one, all multiplied by the LCD. So that's really all we're doing there, multiplying each term, the three original terms in that complex fraction by the LCD. Okay, here's the fun part. We get to clean it up a little bit. Let's cancel common factors. So the x plus 4 cancels in the first one, x plus 7 in the second one, and x plus 7 in the third one. Now, if you glance across all of that work, notice all of the original denominators canceled. That was our goal. So executing this first product, the only thing left is 8 times x plus 7 over 1. I'll just write it 8 times x plus 7. Minus, what we have left here is 2 times x plus 4. And in the bottom, we have x plus 8 times x plus 4. Okay, y'all hang in there. We have arrived at a double-decker fraction, but we need to simplify it, right? Leave the denominator factored, but let's do a little bit of work in the numerator. So I'm going to distribute the 8 to get 8x plus 56. Be careful here. Make sure you distribute negative 2 minus 2x minus 8 and leave that denominator in factored form. Combining like terms in the numerator, 8x minus 2x is going to give us 6x, and 56 minus 8 gives us plus 48. And maintain the same LCD. Okay, looking better with every step, but hopefully you pick up on the GCF in the numerator. We can take out a 6. That leaves behind x plus 8. Now, you can see it's a good thing we factored that numerator because now we can reduce even further. Notice we have a common factor of x plus 8, so we can cancel that out, and we finally end up with the fraction 6 over x plus 4. So what this means, all this work that we've done, our final fraction here, which is pretty easy on the eyes, is equivalent to that original complex fraction, which is pretty complicated. So reducing a complex fraction generates something that's much simpler. Okay, that is our final lesson for Unit 1. It's time to go back over Unit 1, of course, after you finish your 1.5 homework. It's time to start looking at that Unit 1 review and preparing for our first exam. So best of luck to you on that first exam.